Okay, so now after we have studied the closure property, commutative property, now associative property, now we shall discuss the distributive property. Okay, the distributive property holds for natural numbers, whole numbers as well as integers. So we'll discuss all the three cases one by one. So let us consider the case of natural numbers first. So let x, y, z be three natural numbers. So according to the distributive property, we can write this holds for both addition and subtraction, as you all can see. X into y plus z gives you xy plus xz, and x into y minus z will give you xy minus. So this is the distributive property, very simple. Whenever you get three numbers in such a form, x into y plus z, then you can break it down as xy plus xz. If you get to say three numbers in the form x into y minus z, then you can break the numbers in the form xy minus xz. Okay, that is x into y plus x into z. Here x into y minus x into z. That's what we have written here. So now if we are given the reverse order, for example, say we have been given xy plus xz, or we have been given say xy minus xz. So how can we apply the distributive property? So first we discussed when x into y plus z was given, we can write this. So now say for example you are given xy plus xz, or you are given say for example xy minus xz. So how you can write in bracket form? See here x, from these two terms x is common. Okay, so you take x first, start the bracket. In the first term you see that along with x there is this term y. Okay, write y here. In the middle you can see this is the plus sign, write plus here. Here you can see along with x there is the other number which is z, so you write here z. So this is how we write in bracket form. Similarly for xy minus xz, how can we write? You see in both these terms we have x common, so take out x, start the bracket. Don't give plus or minus before the bracket. Now you see that x is common and now we have y and z. Okay, in both the terms x is common. So for the first term you write here y, you have a minus sign in between the two terms, so write here minus. And in the second term along with x you have z, so you write x, y minus z. So this is how you form the bracket form of the distributive property. So if you are given x into y plus z, what will you do? Multiply x with y first, xy, give the plus sign here, and then multiply x with z to get the second term xz. Similarly for x into y minus z, multiply x with y, you get xy, give the minus sign here, and then for the second term multiply x with z to get xz. This is how we do it. So this is for natural numbers. Okay, let us say take an example. It will be more clear if we take an example. Jikono tinta natural number loa, 3 loa, 5 loa, 7 loa. ঠিক আছে? বেশি ডাঙৰ নাই লোৱা, ক্যালকুলেশন কৰিবলৈ যাতে সহজ হয়. It should be simple so that we can calculate faster. Okay, so according to distributive property, how can we write? If we are given say for example three numbers of the form 3 into 5 plus 7. Okay, so according to the distributive property, how will you break it down? আমি কেনেকৈ লিখিম এটো? 3 টো যেহেতু কমন আছে, so 3 টো প্ৰথমতে আমি লিখিম 3 into কোনটো টাৰ্মৰ লগত মাল্টিপ্লাই হ'ব? 5 ৰ লগত মাল্টিপ্লাই হ'ব 5. এটো আহিলে ফাৰ্স্ট, তাৰ পিছত মাজতে আছে তোমাৰ মাইনাস সাইনটো দি প্লাস সাইনটা আছে, তো প্লাস সাইনটো দিবা। আৰু তাৰ পিছত সেকেন্ড টাৰ্মটো আমি কেনেকৈ লিখিম? 3 into 7 কৰিম, 3 into 7. So 3 into 7. আৰু দৰকাৰ পৰিলে বা যদি মন যায় এনেকৈ ব্ৰেকেটটা দি দিব পাৰা, কোনো প্ৰবলেম নাই, নিদিলেও কোনো কথা নাই। So 3 into 5 মানে কিমান হ'ব? এতিয়া আমি ভেৰিফাই কৰি চাম যে লেফট হ্যান্ড সাইড আৰু ৰাইট হ্যান্ড সাইডটো সেম হৈছে নে নাই। ঠিক আছে, so 3 into 5 plus 7 বদমাছ ৰুল যদি লগাও তেতিয়া কি হ'ব? আমি ব্ৰেকেটৰ ভিতৰৰ বস্তুখিনি প্ৰথমতে কৰিব লাগে। We have to compute the operation inside the bracket according to বদমাছ rule. BODMAS. So we have been given a bracket. So inside the bracket, whatever numbers are there, we'll do that operation first. So here we have 3 into 5 plus 7 is what? 12. 12 3s are 3. Bracket 12 means 3 into 12. Everybody must know this. 3 into 12 is 36. Okay. So here we'll see if we get the same number or not. So 3 into 5 plus 3 into 7. Okay, we do the bracket part first. 5 3s are 15 plus 7 3s are 21. So 15 plus 21 is 36. So this 36 and this 36. So distributive property is satisfied, or you can say distributive property is applicable. So similarly, if we take one minus case, the case of subtraction. So in case of subtraction, how will we do? Pretty simple, just like this property, very simple. So let us say take another three numbers. Let's not take the same example. Let's say take three different numbers. Say we have taken here 4, 5, and we have taken here 3. Okay, so we'll see what can be done here. 4 into 5 minus 3 is equal to 4 into 5 minus 4 into 3. How are we getting this? Because this is the distributive property. 4 is to be multiplied first with 5. So 4 into 5. We have a minus sign here, so minus sign goes here. And then for the second term we have 3 and we have to multiply 4 with 3, so 4 into 3. So now we'll see whether LHS is equal to RHS or not. So LHS, what do we have in LHS? LHS means left hand side, okay? The left hand side of the equation. So 4 into 5 minus 3 is equal to 4 into 5 minus 3 is 2. So 4 2s are 8. This is again the BODMAS rule. Within brackets, whatever numbers are there, bracket of bhitor jikhini number ase, hey number kitar operation to ami agote kori lobo lage BODMAS rule mote. So 5 minus 3 korilu kiman palu? 2 palu. So 4 2s are 8. So here 4 into 5 minus 4 into 3. Okay? So 4 5s are kiman palu? 20 palu. Minus 4 3s are kiman palu? 12 palu. So 20 minus 12 is 8. So 8 milise duta 8 to 8, 8 to 8. So here to distributive property satisfies it. So we have taken here two examples to show that distributive property will hold whether it is addition or whether it is subtraction when it is the case with natural numbers. এতিয়া হোল নাম্বাৰৰ ক্ষেত্ৰতো একে হ'ব, কাৰণ হোল নাম্বাৰ আৰু নেচাৰেল নাম্বাৰৰ মাজত ডিফাৰেন্সটো আমি গম পালো যে অকল 0 এটা এড কৰি দিলে নেচাৰেল নাম্বাৰৰ লগত যদি 0 এটা এড কৰি দিও তেতিয়া গোটেইটো হোল নাম্বাৰ হৈ যায়. So in case of whole numbers also this property is applicable because 4, 5 and 3 are all whole numbers also. So similarly যদি আমি এইটো অপাৰেশন কৰো এনেকে যদি কৰো তেতিয়া আমাৰ হোল নাম্বাৰৰ কাৰণেও এই প্ৰপাৰ্টিটো satisfy হ'ব. So I hope that I will not have to show it for whole numbers also because it is exactly the same as we have done it here. Okay, now we'll go to integers.